Okay, ladies and gentlemen, good morning, and my apologies for missing the meeting today because I thought it started at 9:45, and sorry about that. I wasn't aware of the early class at all. So, but I talked with Mahi, and this is the way we can make it up. So not bad. Let me see. There's a little bit background noise here. Let me see. Uh, yeah, let me mute you all so we don't have any background noise. Okay. Very good. We have a couple of students in classroom right now. This session we will cover. Okay. All right. So in this session we will cover confidence interval, and each session I will probably record for like 15 minutes. Okay. So we have 3 hours with the break time included, and so this section we will focus on confidence interval. Next section will focus on hypothesis testing, and then the last one we will focus on regression. Okay, and the project 3 will be assigned in the third section. Okay, and that's a very important part, because you must listen to all these 3 audios, and understand every section, especially the third section, because I will require you to find a data set that can be applied, through which you can use the multiple regression method and logistic regression for your project 3 to be presented on the 6th class. Okay, and now let's get into the content about confidence interval. Okay, we know that we cover the descriptive statistic, and in descriptive statistic we describe data, and we describe data in the 5 aspects: center, variability, probability, shape, and outlier. And center include mean, median, mode. Variability include variance, standard deviation, including population variance, standard deviation, and the sample variance, sample standard deviation, average deviation, and so forth, or range. And then probably through the center, mean, and standard deviation, we can calculate the probability, and then we can also show the shape, and then to identify outliers. So this is basically what we do in descriptive statistics. But we are not always so fortunate to have the population data, because population is usually big, and to get population census data, usually we need to spend a lot of time and resources, and sometimes it's not even possible. So in that case, depending on the sampling, through the sampling, we get a sample from the population, and to make inferences about the population parameter. But relation parameter, we mean population mean or population standard deviation. Okay, so but what are the estimators for these population parameter? They are the sample mean and sample standard deviation. Sample mean is the unbiased estimator for population parameter, which is population mean. When I say parameter, that means the mean or standard deviation. Okay, the two most important things we describe and we want to describe from a set of data or from the population census data is always the center first, and then how widely spread out, what's the variability from the center. That's always something we want to know. Okay, so but because of the luxury of the data, we don't always have them available, so we use the interval estimation. Why interval estimation? Like confidence, right? We are estimating a population mean, but there are different ways to estimate the population mean, which is through the sample mean. But if we only have sample mean and to estimate a population mean, that would be like firing a rifle bullet to shoot at the target. But since we are missing a lot of the information, we are not taking census. We are only taking a very small subset of the population. So most of the time we miss the target. Okay, you miss a little bit, it's still missing the target. So this is not the best strategy. Then the smart statisticians find a way to work that out. Okay, then we say now that it's difficult for us to shoot the target with the rifle bullet, like hit it with a point estimator, sample mean. Then how about let's construct an interval? We, instead of using a point estimator to estimate the population mean, okay, then we use an interval to estimate the population mean, and that will increase the probability of capturing of the hitting the target with the range, because the range is give you larger probability, give you larger coverage. Okay, so that is basic the rationale. It's somewhat like excuse me. You use a shotgun bullet, okay, instead of a rifle bullet to hit the target. Shotgun bullet hit the target with the range, and that range is similar to the interval. So in in statistics we use an interval to estimate the target, which is the population mean in this case. We don't just have the population mean as target. We may have population proportion down the road as the target. We may also have population standard deviation as the target. Okay, and we may also have more than one population parameter as target. We have what? The difference of two population mean as target. We also have the difference of two population proportion as target. We also have the difference, the ratio of two population variances as target as well. So these are at least we have 6 or 7 different set of targets, and we also have the paired mean. Okay, paired mean as dependent observation, dependent variables as target. So these are the targets that we want to estimate, we want to shoot with our estimators as like bullets in my analogy. Okay, but as mentioned, we use the interval instead of just a point to estimate the target. All right, now, so a point estimate is a special value, a specific value of a point estimator. All right, so the point estimator for population parameter mean Okay, in this case is sample mean. Okay, and a specific value of sample mean you draw from a sample is called a point estimate of the point estimator. Okay, and it's used to estimate the parameter population mean as a parameter. Okay, now and we have what confidence interval. That's why we call it confidence interval estimate. Confidence interval is an interval. It's a range. Okay, an interval number is obtained from a point estimator or estimate of a parameter, and then with the sample mean in this case as the center, the sample mean as a center, and with the margin of error to build this width, this interval. I'll show you the detail. And then the confidence level means we have that parameter lies in the confidence interval. Okay, that means the confidence interval contains the parameter, and that means we capture. If that interval contains the parameter, then that means we hit the target, and that's a job done. That's what we are after. We create an interval in order to estimate the population parameter. Okay. Again, population parameter is a general term that could include mean, that could include a population mean, that could include population standard deviation, that could include population proportion, and that could include two population difference, mean difference, and so forth. So it's a general term now. In this case, we'll focus on population mean. And then, so this kind of confidence interval, we call confidence interval estimate. Instead of doing a point estimate, we're doing a confidence interval estimate to increase the probability of our hitting the target with our statistical shotgun bullets. Okay. Now, and you look at the this chart, and you will see an example illustrating the idea of a confidence interval. For example, 20 confidence intervals for the mean price of all new mobile homes, each based on the sample of 36 new mobile homes. So we know in US, or even in Europe as well, we have many mobile homes. People love to travel and drive their mobile home. You don't have to pay for the hotel and so forth. Now, but you just can make so many phone calls to figure out the prices of different mobile homes, because there are different sizes of mobile home, years already used and new, whatever. So that's simply impossible task. Too many, too expensive if you are to do a census. That's crazy. So you take a sample, 36 observations, 36 mobile homes, and every time you take a sample of this size, you will be able to create a sample mean and a sample standard deviation. Then with that, you construct a confidence interval. All right, and here you see 20 intervals constructed to 20 different samples. So this is how the concept of confidence interval is applied. Is that let me move this? Okay, is applied that out of for example, 95% confidence interval means that we are 95% confident that this interval will include the mean, population mean. You see the dashed line, mu, that's where the population mean is. And out of 20, so 20 times 95%, you get 19. That means out of 20, you will have 19 intervals hitting the target. Now, this is a case with, in this example, you have one, you see the red, you see here that it missed the target. It missed the target. So that is the problem. I mean, not a problem. That is the percentage we can tolerate. We allow 5% error. You can do without error unless you make the interval very big, or if you make the interval very big, then you don't in a real sense you don't have accurate or precise information. I can make the interval so big that I will never make a mistake, but then I also don't have any information. So our goal is to make the interval short as it can be. That means precision. And then, also meanwhile, increase the confidence level to as close to 100% as possible. Usually, it should be from 90% to 95% to 99% confidence interval. That are the most commonly used level of confidence. Okay, all right. So now you got the basic idea. Or if you continue to increase the number of samples you can draw, then out of 100 samples, approximately 95 will hit the target, and 5% will not hit the target. Excuse me. So now you see the rationale in the interval estimation. Okay. Turn to next page. Okay, and there are different scenarios. We have confidence intervals for one population mean where sigma is known. We know sigma is an important piece of information. Okay, if sigma is known, then the variability decrease, and then we can use z distribution. The characteristic of z, which is a standard normal distribution, as we have covered before, is that this z is a bell shape, and 99.7% fall within 3 standard deviation to either side of the center. And in this slide, you can see that there are 95.44% fall within the 2 standard deviation to either side of the center. Okay. Now, and also because this is a sampling distribution of the sample mean, we the standard deviation becomes sigma over square root of n, because the central sampling distribution of sample mean means that to repeated sampling of a larger sample size through central limit theorem, we are able to approximate any sampling distribution of the sample mean to normal distribution. Okay, so that is why you can see there are two rows here. This is one row. That's a distribution of x bar, with mu as a center and the sigma over square root n as a standard deviation, or we call it standard error. Now it can be approximated by z, which is normal distribution. So through standardizing, you can standardize this value, which is here, 0.0228. No, this is the area. This point is a value, and you can standardize that to 2. Okay, where center is can be equivalent to 0, and then the other 2 points are 2 and -2. So then you make it more general. Okay, instead of using 95.44 within the center, we make it more general. We replace that the two-tail area by alpha. So alpha over 2 on two tails, and the central area will be 1 minus alpha. Then we make it more general to formulate, to become a formula. Okay, and that become a formula through which we can construct a confidence interval for interval estimation. Okay, well, there is a software that very simple software. Of course, I don't want to confuse you by giving you one more, but it's indeed very handy. And once you come to the interval estimation or hypothesis test, it's very useful, very easy, and the answer will be just clicks away. So I would suggest that you may download. It only takes 1 to 3 minutes, and then download it, install it. It's not fancy at all. It's not super powerful, but it's very handy. Okay, so so this is your formula. As I mentioned, X bar is a point estimator, and then Z alpha over 2 times the sigma over square root, and this thing become the margin of error. So with X bar in the center, you plus minus margin of errors, then you construct an interval to which you can capture the target. Okay, to which you can capture the target. And I will show you how to use status to construct an interval. Of course, I will show you, excuse me, I'll show you how to use Excel to construct the confidence interval as well. Okay, so in this example, we have sigma known. You see at the bottom here, right here. So sigma is known. Then what we can do is that we use the Z test, Z to construct a confidence interval. Okay, here's some instruction using statis. I will show you how to use statis. Look, what you can do is that you go to statdisk.org. statdisk.org. Okay, and then as I mentioned, this is not even like Excel. It's very easy to learn, so only 30 minutes you can get a hang of it. Okay, you can open an online account. If you don't want to download it, open an online account. You can use it online, or you can download the 13th edition to the Windows or to the Mac. Okay, and there are videos for you to watch using how to use statis for using statis or Excel as well. So if you want to know how to use Excel in constructing confidence intervals, there are many videos for you to get into the details as well using Excel. All right. So it's definitely a very good tool to have. Okay. Let me see. Video, if you click on the videos, there are, okay, so excuse me, a little bit slow. Let me see. Yeah, you will see the status, you will see the Excel videos. Okay, this is how to use statis. Excuse me. So you click on video, Excel, click on Excel. All right, so you will see a bunch of Excel videos, and everyone are short. So pick the one that you want to use Excel in doing the descriptive and inferential statistical analysis. Okay. Yeah, this is a very good tool. All right. Okay. Now what you should do is that is this. Okay. Now let me see. Let me check. So okay, let me check. So far so good, everyone. Okay, everybody. Okay, good. Okay, very good. Okay, now let me open the status. After you download it, install it, you shall be able to see this icon, and then you click on analysis, confidence intervals, because we are working on the population mean as the center. So you choose mean, okay, and then you only have one sample. You take one sample from one population, and to construct the confidence interval for the mean. And that's what we do. So you pick this one. And the confidence level is 95%. Sample size. Let's look at the question here in the PowerPoint. The question we have here is sample size is 50, means 36, 38, and population standard deviation. Remember, this is population standard deviation, not sample standard deviation. So 50, 36, 38, and 12.1. 50, 36, 38, 12.1. But 12.1 should be right here, not up there. 12.1 because it's population standard deviation. Then evaluate right here. You got an interval. So what's the question asked? The question is about the age in civilian labor force age estimate. So you construct a confidence interval. Let's say the average civilian labor force ranges from 33 to 39.7. Okay, and you have margin of error 3.35. So look, this is how you construct the confidence interval. You do 36.38, which is the center mean, okay, plus 3.35, 38, you got the 39.7. And then you do 36.38 minus the E, margin of error, you get the lower bound. So you have upper bound and lower bound as a 95% confidence interval. And you can say that we are 95% confident that the this interval capture the mean, population mean. Okay, this is your confidence interval, right? So and you are 95% confident about it. Okay, so this is the way we use it, and there are many applications, right, in the financial industry. You want to estimate you want to estimate the profitability, okay? Profit in this year. You may construct the confidence interval. You want to estimate the return rate, okay? Investment return rates. You can construct a confidence interval. You want to estimate something, you can construct a confidence interval. When you don't have any slightest idea about what the population mean could be, you draw a sample, hopefully that's a representative of the population, and that's another subject to study, which is how to draw a good sample, okay, which is representative of the population. But okay, it shows that I use free Zoom, and it has a 40 minutes limit. So I will, if we got disconnected, I will get back on. So don't worry, we will split the videos into different episode of maybe 40 minutes because due to the limit. Okay, don't worry if we got cut off after 40 minutes. Okay, maybe in 10 minutes, but come back on. Okay, log back on. Okay, so we see this. Now let's move on to the next slide. Okay, so here and we double click to add the titles. Sorry, this is not the title. We see the interval. You know, the smaller confidence level, the shorter, the more narrower the interval will be. If you want to increase the confidence interval, you have a larger. You increase the confidence level, increase the the interval width. Okay, and that makes sense. Think about, you here is a peg and you want to hook the peg with ring, and if my skill of hooking the peg doesn't improve, then of course using a bigger ring will increase the probability of hooking the peg. So the same scenario applies here. Okay. All right. Now we also see margin of error. Margin of error comes from what? Missing information. Why are there error? Because we are taking a subset of the population, and that's why where error comes in is unavoidable. So what we do is but what can we do about it? We change the number of sample. We change the sample size. We change the number of observations. If we increase the n, then as you can see from this formula, n is in the denominator. So if you increase n, that will decrease your error, e. Okay. And suppose we increase n to infinitely large, to an infinitely large number, then what will happen? What will happen is that e will become 0, because n is infinitely large. Then this thing goes to 0. Error becomes 0. And what does that mean? When does n goes to infinity? That means you take a census. When you have a census, you know everything about the population. You know the inside and out. For example, you want to know what's the average French household monthly saving amount, right? Don't you want won't that interest you? What is average monthly saving after they pay all the expenses, the fees, and so forth? How much money do they have to save in their bank account for their wagons, right? You know, so you may be interested in knowing this, and so you go about and collect a sample and ask around, oh, how much you may make, and I mean, how much money you can save per month after you pay for all the bills. Then you construct a confidence interval using statistics or Excel. Then you will construct a confidence interval that say, well, 400 to 600 euros per month. All right, in average, some may have 2,000 to save, but some may have only 50 euros to save. So that's different. Okay, but in average, you get construct an interval from 400 to 600. Okay. All right, but yeah, but if you increase, if you ask everyone, if you get the time and the money, and you can do so, then what? Then you don't need an interval because you know everything. But again, I say that's an impossible in real world. Nobody have the time and the resources to do that. So we always depend on samples. All right. And samples must have error, and that's where margin of error come in. Okay, so you can so if your company asks you to estimate that, oh, what do you think is the average monthly household saving? If you work for a bank, and you want encourage people to save money, to deposit money in the bank account, then what? Then you need to do an estimate of the average monthly saving per household. Then this is a way you can do it. All right. Okay. Now talking about the estimating sample size. Well, this is an interesting topic because you know, sometimes we may want to limit our error. Because, for example, in the presidential election in the US, there are situations when the candidates are very close in their supporting rate. Okay, usually, normally speaking, if 50% of the voters support a certain candidate, then they will win the vote. Okay. Otherwise, they they lose the election. They win the election or lose the election. But if your survey result ranges from what, for example, 51% to 51% is a proportion, okay, and the plus minus margin of error is 3%. Then what happened is 48. Then what happened is that the interval for it is 48 to 54, and that includes 50%. So with that interval, you cannot say no. One of the two candidates will win the other. You cannot say so. So what you should do is to decrease the margin of error to like 0.5. When you do that, decrease to 0.5, then your interval will 5 to 51.5, and that will what? That will that will not include the. That will not include the. Let me mute some of the newcomers. Okay. Okay. Then that will not include the 50%, and that's when you have a confidence to say, okay, the candidate A or candidate B will win the election. But the price you have to pay to control the margin of error is that your sample size will increase accordingly. Okay, and that makes sense because, you know, sample size is information. The larger sample size you have, the more information you will get. Of course, the price you have to pay for doing that is time and resources again. Okay, all right. So anyway, so this is the rationale. Okay, let me give you a heads up. I'm using the free Zoom room, so it may close my session after 40 minutes. Okay, as is showing here in my screen, I have 1 minute and 20 seconds to end the session. But don't worry, just come back in. Okay, come back in. We'll continue. Don't worry about that. Okay, and then we will have break. I'll only use a restroom break like 2-3 minutes or 5 minutes later. Okay, don't wait. So keep coming back. Okay, and keep coming back. But at any rate, I will record the meeting, so those who cannot attend will be able to listen to it to make up the class we missed today. Now it's closing. Oh, anyway, don't worry. Let me see. Close session still. Oh, we are still here. Okay. That's a minute. We'll see. Okay. Anyway, I'm using the free one, so it's keep warning me. Don't worry. Okay. If it doesn't stop us, then we just continue. Okay. So now look at the confidence interval for population mean when sigma is unknown. Okay. When sigma is unknown,